Hi everyone, this is David Blakey, and this video is about Python tuples. What is a tuple? You can see tuples listed and some basic usage at the beginning of the Session 3 handout, right after lists. Tuples look a lot like lists, really. In fact, they are a lot like lists. Tuple constructor looks like this. As you can see, if you were to compare it to a list, like a list, a tuple contains objects, other objects. It's a sequence. It's an ordered sequence, meaning that we can access each element by index positionally. So we can say first element, second element, third element, index 0, index 1, etc. And its constructor is very similar to a list. It just begins with a parentheses instead of a square bracket. So what makes tuples different from lists? Let's talk about some more similarities. We can iterate through a tuple in this way. We can print or access elements of a tuple, the first element, the last element. We can even access slices in the same way. Here's the first through third elements. Why not? It's exactly what we need. I'm sorry. It works in the exact same way as a list. As you can see here, the output's not that clear since I didn't put any intervening print statements, but here we're printing first all the elements in a list, then we're printing two of the elements, the first and the last, and then we're printing a slice. Actually, it looks like the slice is giving us everything, so let's narrow down the slice, the first and second elements. We just get the first and second elements, 1 and 2. Okay, so once again, we're looping through the every element, right? So that's why we get all 4, each on a line. We have requested and printed the first element and the last element. And that's these, first, second. And then finally, we ask for a slice and print a slice, the first and second element. And we get back a tuple slice. So a list slice gets us back a list. A tuple slice gets us back a tuple. So what's different about a tuple? We can see what's the same. Tuples are read-only. So we could try to change an element. We could try to append. Try those. Well, we get a problem. Tuple object does not support item assignment. This is us trying to change an element of my tuple. We're trying to change the first element to hello, but it doesn't work. Let's take that line out, see what happens as we try to append to a tuple. There is no attribute append. Let's see. Okay, well then my question then would be, what do we have available to us in a tuple? I'll open up the Python command line interpreter and say dir tuple. We see a lot of special methods or special attributes that we're not going to pay attention to, but we only have 2, it looks like, that we're invited to call. One is count, the other is index. Count you may remember from string methods, index also. String methods that allow you to inspect the object, inspect the value that's in the object. But there's no method here that allows us to change the object in some way. And that's because tuples are read-only. They're immutable. Tuples are immutable. Tuples are immutable lists. Often the question comes up, why a tuple? It's something that's pretty much unique to Python. Perl certainly doesn't have anything like it. The answer is an immutable list is more efficient. So if we know that the list isn't going to change, or we want to make sure that it won't change, we can use a tuple. A lot of times tuples are what come out of other libraries or modules. For example, a database module might return a row as a tuple. The idea here is that it's not trying to return a structure that you can then go ahead and change, because you may not need to change it or you may not want to change it. If a function or a library is returning a structure just to get you back the values, a tuple is probably the most efficient one that it could use. Same thing would be true of your programs. If you ever want to create a list that you know isn't going to change and that you don't want to change, you should use a tuple. What it allows Python to do is allocate the memory at the beginning of the program execution. And then Python knows for sure that that memory will never have to be reallocated, which would be true of a list. We had something called an empty list, and then we were to append to it, and we were to append to it 20 more times. Eventually Python, and if we were to keep going in this way, which we certainly might do, eventually Python will have to reallocate memory for that list. It didn't know until program execution how much you were going to append to the list or how much memory it might have to allocate. So usually what Python does is allocate an additional amount of memory just in case you do append to the list. That's terribly inefficient, or it's only inefficient in the sense that if you know that the list isn't going to change, there's no sense in using a list where memory may be allocated that's never used. Better to use a tuple. So, as I said before, we can do a lot of things with tuples that we can do with lists. We can use for. We can use subscripts. We can use slices. And we can use the operators in and len. So certainly len should be legal. It's legal for strings. It's legal for lists. And there's no reason it shouldn't be legal for a tuple. And of course it is. As I've said before in class, you can expect that if it makes sense that it should work in a certain way, then it probably will. Here's a 4-element tuple. We're printing the len of my tuple. We're getting back that integer 4. So that is the lowdown on tuples. Not a lot to have to remember, just that we use parentheses and we can treat them like read-only lists. One other thing I will mention, however, it is possible to create a list that is a tuple, rather, without having to use parentheses. It depends on the usage, because sometimes the syntax can get the Python interpreter confused. But you can see here we printed my tuple 2. My tuple 2 is a 4-element tuple, and there was no real way for us to tell that it's a tuple because there's no parentheses, except to know that if you see a bare list with no parentheses, it's most likely a tuple. And we'll see examples of that as well going forward. Okay, thanks for watching.